All right, hello everyone. Welcome back to another one of our flipped lessons. So today we're going to talk about recursively defined sequences. And throughout this video at all, make sure you pause it, you get stuff down, written, copied as you need. I am going to just kind of continue talking. So as you need, just pause it and then get yourself caught up. So there's not going to be a whole lot of pause time in here. Okay, so a couple of our big definitions that we need to make sure that we get down. Our essential question: how can you define a sequence recursively? So that's our goal for the end of this lesson, is to understand how we can define sequences using that recursive formula. First thing we need to define is the explicit rule. So this right here. Sorry about that. We'll just have that go away. Okay, so the explicit rule. Arithmetic and geometric sequences. So this explicit rule follows or goes with both arithmetic and geometric. Remember, arithmetic is addition and subtraction, mainly addition. And then geometric deals with multiplication. Remember, instead of saying divided by 3, we'll say that we're multiplying by 1/3 instead. And just for these sequences, it basically gives a sub n as a function of the term's position number in the sequence. So you're able to kind of figure out from it the next term using previous term, so on and so forth. And then the recursive rule gives the beginning terms of a sequence. Now that's important for us to know. You are given the beginning term, and in some instances you're going to have to give the first 2 terms of a sequence, and those type of problems will be the last ones that we cover. But giving the beginning terms of the sequence and a recursive equation that tells how a sub n is related to one or more of the preceding terms. All right, so hopefully you've got those definitions down, and if not, just pause and keep writing. But I'm going to move on to the next slide. So our core concept, make sure that you have these 2 formulas down. You are going to need them. We're going to use them a lot in this lesson. So a recursive equation for an arithmetic sequence, you're having a sub n equals a sub n minus 1 plus d. Remember, arithmetic, we're adding. So that d is the common difference. We'll also end up thinking about this. I mean, really, this recursive equation is just kind of in the form of y equals mx plus b. Arithmetic sequences, remember, create lines because that common difference is the same. So it's, yeah, it just creates a line. Recursive equation for a geometric sequence. A sub n equals r times a to the n minus 1. R is that common ratio. So whenever we talk about geometric sequences, we talk about multiplying, and R is that common ratio, what we end up dividing by for each of them. Now, I'm not totally sure if I've spent a lot of time talking about like this piece right here, this a sub n minus 1. Basically, a sub n minus 1 is just the previous term. So that's something to, again, just keep in the back of your mind, especially for, not necessarily for the first couple of examples where we're just graphing, but for the examples on the back page, we're going to definitely need to understand what n minus 1 or that a sub n minus 1 means. All right, so hopefully you're all caught up. You've paused the video where you've needed. We're going to go into the first type of example. Write the first 6 terms of each sequence, then graph each sequence. Okay, so on your notepacks, do you see you have a sub 1 equals -2. This right here is our first term. Now, in order for us to find the subsequent terms, so our second term, our third term, our fourth term, fifth, and sixth, sorry, those look like 9s. They're supposed to be A's. I'm not super great at this whole tablet thing yet. I'll get there though. It's really important for us to know the first term, and actually, because of that right there. So I was wrong. It actually does show up in these examples. So what's going to happen here, you guys? To find our second term, you have to take -2 times. So this is the second term, right? So we would do -2 times a to the first power, because you've got n would be 2. Let's see. I want to erase that. I don't want that there. So you would plug 1 in, excuse me, you'd plug 2 in for n. 2 minus 1 just gives you 1. So you're just taking -2 times the first term. So our second term would end up being negative. Oh, no, wait. This is -2. So +4. Let me just throw that -2 in there. And then you're just following that pattern. To find your third term, you're taking -2 times the previous term, which is 4. So -2 times 4 gives you -8. For the next term, you're taking -2 times -8, which gives you 16. -2 times 16, which gives you -32. And then -2 times -32. End up multiplying those together, and that gives you 64. Okay, so we found all of our first terms. Now the next thing that we have to do is we have to go ahead and we have to graph these. Okay, so let me just get my graph together really quick. I want this to be that color. Okay. So obviously we want that to be a little bit straighter. And actually, I am not going to start that line there. I'm going to start it. Let's go up here. And then I'm going to have my scale actually be by tens so that I can hopefully fit that 64 on there. It might be a little close, but 10, 20, 30, 40, 50, and then 60. For that 60, it's going to just have to be off. And then we've got -10, -20, -30. Okay, so let's go ahead and let's graph these points really quick. So my first term is at -2. So 1, -2. So that's just kind of right there, really close to the x-axis. Our second term, I'm at 2, 4. So almost halfway, but not quite. 3, -8. Then I'm at 4, 16. I'm at 5, -32. So that's kind of off here. Should be a little bit closer to 30. And then 6, 64. So that's going to be way up here. So this kind of has like a weird pattern to it where it's just going over and under the x-axis, which is kind of weird, but that's what you get when you have a common ratio, excuse me, when you are multiplying by a -2. Okay. So we just did a geometric, and now we're going to go ahead and we're going to do a arithmetic. So one where we are adding. Right? So it's kind of, again, in that form of y equals mx plus b. So this should create a straight line for us. Again, just kind of getting ourselves ready. Our first term is -4. We're trying to find the first 6 terms. So a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. So for our second term, we're just taking -4. Right, so instead of having a 2 there, that's 2 minus 1, which turns into 1. So that previous term plus 3. So our second term turns into -1. Then for our third term, we use the previous one, so that -1 plus 3. So that gets us 2. For our fourth term, again, we're using the previous, so we're using 2 plus 3. And we've got 5. 5 plus 3 gives us 8. 8 plus 3 gives us 11. All right, so again, I'm just going to create this graph. And I'm actually going to, let's see, do that. I'm going to have the scale go up by 2s. So I'm going to do -2, -4, 2, 4, 6, 8, 10, 12. All right, so let's graph these points really quick. So I'm at 1, -4. There's that first point. And then I'm at 2, -1, so about halfway here. 3, 2, 4, 5, 5, 8, and then 6 and 11. Okay, so we do have ourselves an arithmetic. Again, it's just a straight line. What I would love for you guys to do on the next couple of examples, so I believe you have 4 left, try them on your own. Pause the video, see if you can come up with the graph and the work for 3, 4, 5, and 6, and just kind of quiz yourself. I'm going to pause the video right now on my end, and I'm going to fill in all of the stuff, and then, yeah, just check your stuff. All right, you guys, I'm back. So here is my work for the next 4 problems. It's not great. It's actually really hard to write on this tablet thing. But here's my work. So just kind of go ahead and check your stuff out. Again, the third one should be geometric. So it's got more of that exponential shape to it. And then number 4 should be arithmetic. So it's got more of a straight line to it. Number 5, kind of, again, is more like that first one that we did, where it's kind of jumping all over the top or above and below the x-axis. And then I should have changed that last one to number 6, so I apologize. That should be number 6, and that should be a straight line. All right, I am going to be done with this video. I'm going to go ahead and create another video for the next couple of examples, and then, actually, you know what? I'm just kidding. I'm going to do these next couple of examples. Never mind. All right, go on to the next video.